Hello again. Switches, use the pen. There is a topic that has been removed from the blueprint of the new CCNA, which was called collision domains and broadcast domains. This was a main topic in the previous two versions of the CCNA, but I have looked the entire new blueprint and it wasn't mentioned, so maybe Cisco don't want you to know these topics anymore. Anyway, collision domain was that the domain where collision might happen. Okay, so if I used a switches in the past two videos, we said that they have lookup engines, they do schedule frames forwarding, use the MAC table, they have a table lookup engine, so no collision will happen because of the CSMA over CD, of course, also with it. So no collision will happen. That is why this is a collision domain, can be considered as a collision domain, this entire link, and this link is a collision domain. This one also is a third separate collision domain. This is a fourth collision domain. What I have used to teach to my students in the previous version of the CCNA, it was an live lectures and instructions, is that when you have a switch or a router, every single link of the switch or the router is considered a single collision domain. This is where collision happens, and no collision will happen in switches and routers. Collision were to happen previously in hubs, and they are obsolete by now. Okay, so these are collision domains and broadcast domains. This is a much more simpler concept. When you hear the word broadcast domain, this means a network. That's it. Okay, broadcast domain is a network. Why? Okay, we have a router that has two links. Each single link of a router is considered a broadcast domain because routers are the only devices in the networking world that has the ability to make each single port of them a broadcast domain, a network. Okay, you know, we talked about most of the routers do come only with two ports. One port can be connected to a switch, and this switch can be connected maybe to multiple devices. The other port is also connected to a switch that is connected to other multiple devices. So this is separate to have. This is an entire network that cannot see this other entire network, but because of switches, these computers automatically do see and communicate to each other. We did a lab in the end of chapter 1. We installed one switch and connected two computers to the switches with no configuration in the switch at all. The computers did communicate together, okay, with no need for configuration on the switch. What does this mean? Sorry, it means that switches are in the same broadcast domain. Switches do not separate broadcast domain. They do not generate or separate networks. A switch is one network. So whatever you connect to this switch is automatically assigned to this network of the switch and will automatically communicate with other devices that are connected to the switch. Okay, in routers, no, each single interface of a router is considered as a separated broadcast domain, a separated network. So you must use layer 3 technologies, the protocols, the routing protocols, to make one interface of a router communicate to the other interface of the router. Okay, this is a router, it has two ports. This port can't see and communicate with this adjacent port. In order to do so, you have to configure routing protocols between these two ports and they will communicate. Okay, this is the function of the routers. But switches and multi-layer switches, no, they are a single broadcast domain device, so they relies or lies in the same network. All their ports by default do behave under the same network, so everything will automatically happen. You can just go and buy a switch, connect maybe 20 devices to this switch without ever connecting a console cable or configuring the switch. Just give IP addresses of the same subnet to the devices, they will talk to each other. That's it. This is the normal and default behavior of switches. Okay, so the moral of all this speech is that, what do you mean is that whenever I need, maybe I have a small company and this small company has a maximum, let's draw this, I don't like to talk without drawing. Okay, maybe it's much more beneficial to you. I have a switch in a company and the total number of the company employees are only 10. This is a manager with his employees. This is the manager of another department with his employees. Okay, each department should have its own separated access to the network. They are only 4 employees and a manager, so that's making them 5, and those are another 5. If I want to separate these two departments from each other, I need to make every one of them in a single separated broadcast domain. So each department of these two departments must become separated in a single new separated network or broadcast domain. This requires me to go to the shop and buy a router, because only routers do separate broadcast domains. Okay, what happened? There is always solution for everything in networks. Okay, what happens later? A new technology said that I can take this switch and virtually separate, okay, this switch to two virtual switches inside the switch. Each one of them will become a broadcast domain and they shall no longer see each other. Okay, this new technology is called the virtual LANs, the virtual local area networks, or VLANs. You will start a progress with VLANs from now until I don't know how many years you will live with VLANs, starting from now. Okay, they should be obsolete in the soon upcoming future, but I don't believe so. Okay, because other vendors and some vendors are, and even Cisco, are using the concept of VLANs nowadays. Don't get confused, but they are using the concept of VLANs in some next generation routers. Okay, so leave this information like I never said it. Anyway, so the concept and the technology of VLANs, the most important technology, layer 2 technology that you will work with and cooperate with, okay, is the VLANs. Okay, so the technology of VLANs said that I can have a switch, I can divide my switch to two broadcast domains. Each broadcast domain will be considered as a virtual local area network, and this is a virtual other local area network. Each one of them will be separated entirely from the other one. No network shall see the other one. If I wanted some networks to talk to see the other networks, this is normal, no problem. We can do so. Okay, but the main reason of VLANs is to separate the single switch to multiple broadcast domains. 1, 2, 3. How many? You can so far take your switch and assign up to 4096 VLANs. 4096 broadcast domain in a single switch. Yes. You don't have 4000 sorry, ports, so we will not really do it in this way, but you will see the benefit in the upcoming labs. Okay, so can I separate hosts from seeing each other? Yes, using VLANs. What will each group of them become? It will become a broadcast domain. Okay, every single port in this switch must become either this state or another state. Now we will start talking about the VLANs technology. Okay, so we have known that I have a switch that has these ports connected to, and what I will do, I will separate this switch in this way. Maybe I will connect this to another switch for another room or other department, and it has some employees connected to it, no problem. Okay, so this is the concept of VLAN. This is a VLAN, this is another VLAN. Maybe in here all of them under the same VLAN, maybe each one of them separated in a single VLAN, no problem. Hope you have understand the VLAN so far. Okay, every single switch port must become. So now we have port status. Now we have something mandatory in the technology of VLAN, which is called port status. Okay, once I have established VLANs and you started using the VLAN technology in my network, in my switches, I must now assign a port status or configure a port status for each individual port in my switch. I have 5 ports used in this switch. I must assign each one of them a port status. Don't be confused. Port status in the VLANs are only two status. Okay, they are either to become an access port or a trunk port. So access port or to become a trunk port. So you have a switch. Let's summarize now. You have a switch that is connected to 5 ports. You want to separate them to two broadcast domain. As an example, you will take the first 2 ports to a VLAN, the second 2 ports to other VLANs, and the third port is connected to a switch. Okay, so now you have to configure these 5 ports for port status. Some of them must become access, others must become trunks. All of them access, no problem. All of them trunks, no problem at all. But you must assign a port status to your ports, okay? Which they will be either access or trunk, no other port versions, okay? In Cisco and other vendors, there are other options, okay? So, what is access port? Access port is every port of a switch, every switch port that is connected to an end device. Whenever you have a port that is connected to an end device, we have talked tens of times before, end devices might be computers, laptops, personal computers, laptop, a printer, a server, an IP phone, an IP camera, whatever this device is. Whenever you have a port of a switch that is directly connected to an end device, this port must be configured as an access port. Okay, so this is the first case, and in my example I have port number 1, 2, 3 and 4. All of them are connected to end ports, so end devices, so all of them will become access ports. Okay, that's good. Okay, this is the first thing. Access ports do not have tags. What do you mean by tags? You remember frames, and frames had destination MAC addresses, source MAC addresses. They have the frame checksum as a trailer, which is something mandatory in the frames. They have the data field in the frame also. When you when your switch gets involved in the world of VLANs and you start using the VLAN technology in your switch, okay, which is this switch, what will happen is that you will separate these two, or you will separate these 2 ports and these 2 ports, each one of them, maybe these 3 ports, each one of them in a single broadcast domain. How will you represent the broadcast domain? How will you say that in my switch the first 2 ports are in a broadcast domain, and ports number 3, 4 and 5 are in another broadcast domain? Okay, by using VLANs. Please be more specific. What do you mean by using VLANs? What will I really do? What will the switch understand, and what will the switch perform? with these 5 ports. What will the switch do to the first 2 ports to make them understand they are separated and cannot communicate the other 3 ports? Okay, what will happen is tagging. Okay, now the switch will add a tag field in the frame of each port, and this tag will include a number. Which number is this? This number will be the VLAN number, because VLANs are known by numbers, and these numbers starts from 1 to 4096. That's what makes the broadcast domain options up to 4096. Okay, or maybe you call it 4096. Okay, so when I want to separate port number 1 and 2, they will communicate together, no problem. But when I want to separate these 2 ports from these 3 ports, I must assign these 2 ports to a unique, specific new VLAN and give them an ID, a VLAN ID, a VLAN number. Let's say maybe VLAN number 10 as an example. Okay, so what will happen is that I will go to my switch, I will say ports number 1 and 2, they will become access because they are connected to end devices, and in order to make them specific for VLAN number 10, I will make them access to VLAN number 10. You will see this in the configuration and you will understand everything in the practical side. Okay, this is only the concept that is happening. Okay, so this is VLAN number 10 assigned to port number 1 and 2. Okay, this is done. For these three ports must be assigned to another VLAN, maybe VLAN number 20. No problem. I will go and say ports number 3, 4 and 5 are access. No, because port number 5 is not connected to an end device, so maybe no problem. Okay, port 3 and 4 are access to VLAN number 20. What will happen then whenever a switch uses frames? Okay, it will add tags. Okay, if you have so far following me, it will add tags. So when computer number 1 sends something maybe to other switch to other place, okay, it will cross carrying the tag of number 10. Okay, and when it receives, it's carrying the tag of number 10 that I need to talk to the computer that lies in the broadcast domain number 10, in VLAN number 10. Okay, this is the behavior or the concept of tags. But what really happens in the access ports, no tags will cross. Let me clear this mess. What are you talking about, please? I'm talking about this switch in this way, divided in this way. Whenever you assign a port as an access port, you need to know that tags are not carried through this port. Okay, the computer will not receive a frame with a tag number. Tags are removed when they cross an access port. Okay, this is something very important to know about access ports. Then when will I use them? We will use them in the other type of ports, which are the trunk ports. Okay, every switch port that must carry more than a 1 VLAN. Now what is this? I will tell you what is this. I will give you a simple specific example that I hope it will clear to you all the confusing that is happening to you. Imagine this. This is a company that has 2 branches. Okay, this is a branch in area number 1, and this is the branch in area number 2. Another maybe state, province, other territory, whatever place. But this company has 2 branches. Okay, in the first branch we have 2 departments. Department number 1, which are the account, what do they call them? The accountant, I believe, the accounting department. Okay, department number 2 This one may be the HR or the sales department. In the other branch, of course, there will be an accounting department, okay, the accountant, and there will be an HR, okay. So in this other branch, I will also maybe separate it in this way. These will be the accounters, and these will be the HR of this other branch. Since this is the same company, and since this departments do the same duty of this department, then they must contact together. In order to do so, I'm sorry, we need to make these two PCs in a VLAN, which will be VLAN number 10. In this computer, in this switch, also in the other branch, we will also make these two computers in VLAN number 10. So now what will happen is the upcoming PC number 1 in branch 2 will try to communicate PC number 1 in branch 1. It will send a frame. It will cross here untagged. After that, the tag will be added inside the switch tag number 10. This wants to cross from this interface, reaching this switch. After that, it will go to this place. This is an access port. It will not send tags to the PC. Then tag will be removed and send it to PC number 1. No problem. Okay, so I can make these two assigned to VLAN number 10. And encapsulation, the term encapsulation will happen inside this port, including VLAN number 10. We will talk about encapsulation, okay, just in a few minutes. Okay, so then for the HR department, which are in VLAN number 20, and to contact these HR, they will be in VLAN number 20. The same procedure will happen next, but once this VLAN reaches this port can carry only VLAN number 10. How will I make it able to carry VLAN number 20 also? Okay, because now I need two VLANs to cross the same one. Which tag will be assigned here? Tag 10 to deal with VLAN number 10, or tag 20 to deal with VLAN number 20? Okay, this is where trunk ports come. Trunk ports are ports that must carry more than one VLAN. Okay, we can use something that is called encapsulation, and this encapsulation has a code that is .1Q. This is a specific from IEEE. Okay, .1Q. What will happen is that virtually inside this port, encapsulation will happen, that it will be divided to two ports. One will carry tags of the VLAN 10, the other one will carry tags of VLAN number 20. If I have 10 VLAN, it will be separated or divided, I'm sorry, to 10 tags. If I have 1000 VLAN, it will be divided to 1000 tag. No problem. Once this port becomes or configured, we must configure it manually. It's not by default. We must configure this port and this port. Please never forget this port also, both of them, to become trunk ports. Then by default, whomever wants to cross from here reaching the other side is more than welcome to cross using this port. Okay, so this is the concept of VLANs, and this is the most important thing about the two port types of VLANs, which are the access ports and the trunk ports. Okay, in trunking, where more than one VLAN must cross, this is done by using encapsulation.1Q we have talked about. Also, you must know something important before we end up this video. Let me clear the mess. Okay, this something is that there are types for VLANs. Okay, and these types are, first one, the data VLAN. This is whatever type of data that you are sending to your friends. You are on VLAN number 10 in the accountment department. You are sending some accountment or some sheets or data to your other colleague in the other branch we have just talked about, also in VLAN number 10. So you will use data VLAN. Okay, just to know, you will use data VLAN maybe in let's say 69% of your study and application implementing in the Cisco CCNA certificate. Okay, the other 4% you will use are called the voice VLAN. In case you connected your switch to an IP phone, this is an end device, but it's not a computer this time, it's an IP phone, and this is more important than data because data can use TCP, if you remember TCP, and can wait in the queue to reach the other side. Okay, but voice, I'm now online and I'm talking to maybe my colleague, my manager, whomever. Maybe I'm talking to the HR. Why are you late in the morning? Justify yourself. And I want to tell them that there was a traffic jam, and because of the internet, because of the, I'm sorry, the data VLAN or some congestion happened in the network, they hear, they say, what are you talking about? Come to the office. Then you say, oh, things got creepy. Okay, so voice VLAN are another types of VLANs that you assign them to IP phones. Okay, assign them to whomever interface that will carry voice data. Okay, it will carry phone calls. Okay, because using voice VLANs you can give them more priority in the bandwidth, in the resources of the network than the data VLAN. This will allow the voice VLAN to cross first, the data voice data to cross first in the network. After that, the data VLAN will follow them. This will lead you to clear and more quality in voice calls. Okay, so this is the voice VLAN. We don't have to perform a lab on this. I don't believe so. In case you want to just inform me, and we will do an extra lab, a challenge lab for the voice VLAN, which has a higher priority. Finally, I don't want this lecture to cross 30 minutes. Okay, this will be annoying to you, but we have two important things. How come that when I establish a switch out of the box, power it up, connect 10 devices to the switch, all of them will work by default without configuring the switch? You must know something before this. You must know that all switches, I believe starting from 1990s or 1980s, they do already become established or operated with VLAN technology out of the box. You just use a new switch, the switch uses VLANs. Then how come that this switch, just when I power it up, it make all the devices communicate together and it uses VLANs? You say that VLANs separate interfaces. How come that all of them are talking to each other before configuring the device when it's new? That's because there is something called the default VLAN. The default VLAN is a VLAN that is by default, okay, assigned to all the interfaces of the switch. And since maybe I have a switch with 24 interface, and all of them by default are assigned to the default VLAN, which is VLAN number 1. Okay, since all the interfaces lies within VLAN number 1, then they can talk to each other, no problem. Okay, this is the point of making all the switches talk to each other. When they become, or when they have reached the level of creating or producing new switches that must operate with VLANs, but then we have to make all the devices communicate without configuration, initial configuration for the switch, then default VLAN become. Okay, to the show. And default VLAN, what it does, that it's by default there in the switch. All the switches are, the ports are assigned to the default VLAN. In Cisco, the default VLAN will always be 1. Okay, and there will be no tags with VLAN with the default VLAN. Another concept is the native VLAN. The native VLAN is also VLAN number 1. And the native VLAN, it is any VLAN that is not carrying tags. Okay, any VLAN in the switching technology, in the switching network, that is not carrying tags. Okay, you have talked about tags. Okay, but if you want data to cross without a tag, okay, you must assign this data or these ports to the native VLAN, which is also VLAN number 1 in Cisco. But what's the difference between the default and the native? Both of them are VLAN number 1 as a number, as an ID. Both of them are, or they do not carry tags. There are no tags in the default and the native. There must be a difference. The difference is that you can change the native VLAN to whatever VLAN you want. You can make VLAN number 10 is the native. You can make VLAN number 101 is the native. I'm sorry. You can make VLAN number 2002 is the native, but the default VLAN will be always VLAN number 1. This is the big difference between VLAN, the default VLAN, and native VLANs. We have talked about all of these lines mentioned or cleared in front of you in the slide. Please comment below in the video, subscribe our channel, share it if you'd like. Okay, press the hit the like button, and comment for any concern or anything about this video or any other videos. We will be more than glad to aid you with. Okay, thank you so much for all the time watching us, and we will see you next and very soon in the upcoming video.